Last class we have done module 3 magnetic circuit. As I told you, two types of question will come from this: reluctance in series and parallel circuits. This one we have done, like inductance, mutual inductance. This one we have done, and rest of the part we'll do it today, right? So basically it's the So now for this, first of all, you should know the difference between the electric circuit and the magnetic circuit. Okay. So basically we'll have electric circuit and we'll have magnetic circuit. Like in case of electrical, we always say that current is flowing, right? And in case of magnetic circuit, we always say that flux will be there. Okay. Now see what is flux. Like suppose there is magnet having north and south pole, and there is a magnetic field lines moving from north to south, right? It is leaving the north terminal and entering into the south terminal, correct? So in this case, flux is there. These field lines, flux is basically field lines per unit area. Okay. So in this case, current is flowing. In this case, flux is there. And in the case of electric circuit, EMF will induced. EMF means electromotive force, right? But in case of magnetic circuit, MMF will produce. MMF means magneto motive force. Got it? Next one, this is the case of, now the next one is resistance. Okay, resistance which opposes the flow of current, but in case of magnetic circuit, that is reluctance. Same work as of resistance here, reluctance is of same work in the magnetic circuit. Reluctance is denoted by S. Reluctance is denoted by S. Basically, if you want to write down, it is the opposition. It oppose magnetic path to flux. Okay, and its unit is ampere turn per Weber. A for ampere, T for turn per unit Weber. Okay. Now in this case, as you know, that resistance depends on the conductor material, right? But reluctance depends on reluctance is inversely proportional to the permeability of the medium. Permeability is denoted by mu, right? So basically we'll have formula related to this, that I is equal to, you know, V by R in case of electric circuit. So I would be equal to V is EMF induced divided by resistance. But in case of magnetic circuit, what we called it as phi, phi is equal to MMF divided by, instead of resistance we will use reluctance, and reluctance is denoted by S, right? Clear? And here we'll have one more formula, that is flux density related. B is equal, phi is equal to B into A. What is phi over here? Phi is the flux, and what is B over here? B is the flux density and A is the area. Got it? Now next formula which you need to use, that is S is equal to L divided by mu naught mu R into area. Okay. What is L over here? L is the length, mu naught is the permeability of the air, that is fixed, mu R is the relative permeability, and A is the area. Okay. Clear? Now we'll have one more formula for MMF. MMF is equal to number of turns multiplied by current, and its unit is ampere turn. Okay, so in this you have lots and lots of formulas. Basically you need to remember those formulas. One more formula related to the MMF is equal to flux multiplied by the reluctance. Okay, flux multiplied by the reluctance. And Yeah, write down these three main formulas that will be used in your numerical. Write it down. One more thing, that mu is equal to mu naught into mu r, that is B over H. Okay, B is the magnetic field density, H is the magnetizing force, and related to this, right? And we'll have H formula also. H is equal to N into I divided by L. Okay, let's do one question, then it would be more clear to you. One more thing, mu naught is equal to 4 pi into 10 raised power minus 7. Got it? Now see in your VIT, this type of numerical will come like they have given a ring shape. Okay, this is completely a ring shape, and they said in the ring they cut it, this one part. Okay, they cut this part. So in this, the cross sectional area is like A, right? And in this question they have given flux density. As you know that flux density is denoted by which term? B, right? B. So B is how much? B is equal to 1 Tesla. 1 Tesla. Tesla is the unit of flux density. Now they have given mu r value also, that is 1000. They have given circumference, that is 100.2 centimeter. You need to convert it into meter, right? And they said that there is a air gap of 2 millimeter. Now see how we can do this question. In this question, first of all, what we need to require, we have to see that MMF, right? And as I just told you the formula, that MMF is equal to phi into S, right? So can we write down MMF is equal to phi into S, right? But we don't have phi, but we have one formula related to the phi. That is what I told you, phi is equal to B into A. I'm writing here only all the formulas. You can mark this heading as all the formulas related to this. Phi is equal to B into A, so I'm writing phi is equal to B into A into S, right? Correct. Now our basic main aim is to calculate S, because flux density they have already given, that is 1 Tesla. Area will remain area as it is, and S formula is what? S is L divided by mu naught mu r into area, right? This one also I wrote it here. S is equal to L mu naught mu r into area, right? Now see what is the unit of MMF, that is ampere turn, correct? Now as you can see that this area and this area is cancelled out, right? So what we need to calculate, mu naught is fixed, as I told you, mu naught is 4 pi into 10 raised power minus 7, right? Mu r also they have given, that relative permeability is how much? 1000, right? Now what we need to calculate, basically they have given the 2s. One S is for the iron ring, right? This one is the iron ring. One S we need to calculate it for the iron ring. Another S we need to calculate it for this air gap, right? So this is basically what? Air gap, and this is basically what? A ring. Yes or no? Okay, so can we say that S ring is equal to L length for ring divided by mu naught mu r multiplied by area? Yes or no? Okay, now see the length of ring iron is how much? The complete circumference is how much? 100.2, right? From this, how much is the air gap? They have mentioned 2 millimeter. So for 2 millimeter, if we convert it into meter, if we convert it into centimeter, because it's in centimeter now, so it should be the same. So it would be 0.2 or not? Okay, so length is how much? That would be 100.2 minus 0.2. Both are in centimeter, but we need to convert it into meter, so that would be into 10 raised to power minus 2 divided by mu naught. Mu naught is 4 pi into 10 raised to power minus 7. Mu r is 1000. A will consider A only because we know that would be cancelled out later on. Got it? See what we have done. The complete circumference of the ring was 100.2 and the air gap was 0.2. So this green portion was left with 100.2 minus 0.2. Yes or no? Okay. So from here we can get the S reluctance for the ring. Similarly, can we get the reluctance for air? Reluctance for air is how much? Again, L divided by mu naught multiplied by area. So you can write it down here also that yeah, mu r is not there because it's not the medium na. Air is for the mu naught is only mu naught will consider because air is not a medium. Mu naught is the permeability of the air only, of the vacuum only, right? So this is reluctance for the air. So length we know that they have given for the air gap, that was how much? 0.2 centimeter. So 0.2 centimeter we need to convert it into meter. You can convert it divided by 4 pi into 10 raised to power minus 7, right, into area, right? So now we'll need to take the total reluctance. Total reluctance is reluctance 0.2 millimeter into meter. What would be the value? You can convert it according to you only. Okay, I am writing here as 2 millimeter. 2 millimeter you need to convert it into meter. Fine. So S total is how much? S ring plus S air. S ring, what we got it as, after solving this term completely, we'll get some value that is 795.77 divided by A for area. S air we are getting as, after solving, 1591.55 divided by A. So after solving it, we'll get 2387.32 divided by A. Okay, clear? So this is our final reluctance. We can put it here. The reluctance, I am putting it here. We got it as 2387.32 divided by A. Again, area cancelled out. Now we got our final MMF, that is 202,830 ampere ton. No, area was not cancelled out. I just told you the concept that how we don't need to focus on area here because in the last area and area will be cancelled out. Okay. We calculated here the S total. I've told you in the starting that we don't need to focus on area because in the last area and area would be cancelled out. Got it? One more formula here. For reluctance we always need to calculate length, right? Length formula is pi multiplied by d. Okay, length formula is pi multiplied by d, that is d is what? The mean diameter. So that depends, they'll give you the diameter, circumference or radius. Okay, so length is equal to circumference only, correct? Note down all these formulas. Now see, in this case you need to calculate MMF, right? So MMF formula is N into I, so that would be N1 I1, N2 I2, N3 I3, right? So as you can see, there is a symmetry in N2 and N3. In this case N2 is also living, in this case N3 is also living, right? So N2 and N3 will be plus, but N1 is this one is different, so that would be minus, correct? N1, N2, N3 values we already know. I1, I2, I3 values we already know. After solving, we'll get 2200 ampere turn. This is the next question. In this question, they have given there are two material A and material B. For material B, relative permeability and length is this one. For material A, relative permeability and length is this one, right? And then it is having air gap. Now we need to calculate three reluctance. One for material A, one for material B, and one for air gap. So formula is same, L divided by mu naught mu r multiplied by area. In this case, area is given 5 centimeter square, length is also given, mu r is also given. So similarly for B, area is same 5 centimeter square. They have mentioned it. Okay, that for both the cases same. Now for air gap also we can calculate it, right? So if we'll solve it, then length is how much? 100 centimeter. Convert it into meter. Mu naught is same, 4 pi into 10 raised to power minus 7. Mu r is also given 800 multiplied by area is 5 into 10 raised to power minus 4, right? Similarly for this one, material B, we can do it 4 pi into 10 raised to power minus 7 into 1200 into 5 into 10 raised to power minus 4. And for this one, L is equal to mu naught into area. So L is how much? The length, air gap they have given 2 millimeter, right? And area is again the same area they have cut it, right? So that would be 2 into 10 raised to power minus 3 divided by 4 pi into 10 raised to power minus 7 into 5 into 10 raised to power minus 4. If you will solve it, you will get this one as 1989436.8. It's long. Ampere turn per Weber. For the second one, 79577.4.7 80 per Weber, and this one is 3183098.9 ampere turn per Weber, and the total reluctance you will get it at after adding 5968310.4 ampere turn per Weber. Okay, now they are asking MMF. MMF is N multiplied by I. Number of turns also they have mentioned 500. Current is 5, right? So it would be simple 500 into 5. Flux is how much? As you know, MMF by reluctance. MMF you already calculated 2500. Reluctance you already calculated. Yes. Now see in this question, the same kind of question. Area is given, length is given, mu r is given, gap is given, phi is given. You need to calculate flux density. So B is equal to phi by A. Phi is there, area is there, right? 2 millimeter. Sorry, area is 6 centimeter square. Now ampere turn for iron, and then L is equal to, L is how much? 0.3, because for the iron length is 30 centimeter, then mu r is given and area is 6 centimeter square. This one is for the ring. Now for the air length is 2 millimeter and area is this one, right? Correct. Now after this you need to calculate magnetizing current, right? And magnetizing current means the normal current. So normal current is, what is the formula? That is F is equal to N into I. N you already know. Force means the force is phi into S. MMF means phi, right? So phi you know, S you know, number of turns already you know, current you can get it. Current after solving you will get it as 34484 ampere, right? Then you can solve it further.